Alrighty guys, version 2 of the 45-degree leg press video. So in this video what we want to do is try and answer how much load you're actually lifting when you have 100 kilos on the leg press. A lot of people feel like they can lift more on a leg press than they can on a squat. Some leg presses are different, some machines are different, and we want to kind of dig into some of the details here. So we made a version 1 of this, but there were some errors in it as a result of trying to oversimplify things. So Einstein supposedly once said that you want to make things as simple as possible but not simpler. And there's also this concept in physics of the spherical cow, where it's sort of a joke that of the spherical cow that, oh yeah, just assume that the cow is a sphere when doing equations. So it's sort of meant to show you that when you try and simplify things too much, you kind of lose what actually happens in the real world. So thanks to John, Jack, and Ian for pointing out some of those errors, but this time we're going to go into a little bit more detail. So what I'll show you here is our graph to start with. So what we've got is our setup here with our 45-degree leg press. We've got 100 kilos on here, but what we want to show you here in these different steps is that you're not actually lifting 100 kilos. We want to figure out how much you're actually lifting. So you've got 100 kilos on here, but it's clearly at an angle and it's at a 45-degree angle. So we want to answer this question: how much are you actually lifting? So what we have to look at here is this slope here. So let's get rid of the leg press for a moment. Look at this as if it's just on a slope. It's 100 kilos on a slope. What you've got is this red line, okay, and this red line is the weight, okay, the weight of that mass. So that's going to be mass times G for gravity, okay. So what that is then going to end up being is 981 newtons, okay, 981 newtons, essentially because you're multiplying the mass of 100 kilos by 9.81, which is acceleration due to gravity, okay. So that's what we've got going on there. All right, then what we've got is this normal force. So this blue line is indicating what's called the normal force. So that's the force that's acting perpendicular to the slope. So that's acting straight in to the leg press this way, okay? So that's just called our normal force. You don't need to worry too much about labeling that. What we're most interested in here is this green line, okay? So this green line that acts between the two to form this small little right angle triangle, that's our resistance. So that's what we're actually dealing with when we start to do the leg press. So we definitely need to label that, and we'll just label it FR. So that's our resistance. That's what we're actually trying to find. You're probably wondering, how are we actually going to find that? And how we find that is by constructing this triangle here. So this triangle is not actually the leg press triangle. It's this small triangle that we've created by doing some of those calculations that we just did. So we move over then to step 3, and this is our triangle, okay? So we know a couple of things about this triangle. That small little angle there, that's 45 degrees. We know that this is 90. So we've got information, and we know that this is our resistance line now. And this is probably a bit more confusing when we do it this way because it's simpler to think of it that way, but this is our resistance line. So this is our FR. The green is the resistance. What else do we know? We know that this red line, we know that that's 981 newtons because we calculated that. So we're getting places. We know that that's 981 newtons. We know that that's our FR. What we can do from here is say sine, okay? Some of you might recall your sine, cos, tan, that sort of stuff. So sine, if you recall that from trigonometry, that's the opposite over the hypotenuse, okay? So what are we actually looking for, okay? We're looking for the opposite of this angle, okay? If we're talking about that 45-degree angle, we're looking for FR. So what we start to do is say that the sine of 45 equals, remember, so, ka, toa. So sine equals so, opposite over hypotenuse. So FR over the hypotenuse, which is the angle or the side across from the right angle. So that's 981. So opposite FR over 981. We're getting places. So then what we have to do is say, all right, so how do we get FR from here? So we get FR from here by saying FR, which is our resistance, remember, equals 981 by sine 45. We have to actually divide that again by 9.81 so that we get the kilogram value, and we divide that by 9.81. We could actually simplify this even more. If you didn't want to calculate this all the way out, you could just, call that 1, call that 100. 100 sine 45. Sine 45 is 0.7071. 0.7071 by 100 equals 70.71 kg. Okay, so you can calculate that a couple of different ways. You can just cross them out like I did there, which is the simple way of doing the maths in your head. Or alternatively, you can just multiply them out and then divide afterwards. But there you go, guys. So that's the longer route to getting this answer, to figuring out that is 70.71 kilos. So we essentially start off with the leg press. We create this smaller triangle. We move that into a bigger triangle, and then we figure out our end point here, which is 70.71 kilos. So hopefully that makes a bit of sense, guys. If you'd like more videos like this, of course, please do ask me. And at the same time, please feel free to give criticism and feedback and point out anything that you think is incorrect, because it actually helps me a lot, because this is essentially a way of pure learning. Because if I'm able to put out information and you guys review it for me, then I can update my information over time and hopefully help out more people. That's always the goal. So any more questions or comments, please drop them down below.